All right, Algebra 2, we are on Unit 4.2, which is adding and subtracting rational expressions with like and unlike denominators. So we're going to go back and kind of review how we did fractions from elementary school, junior high, and then we can apply that to these expressions with variables. All right, so on this first one, 2/3 plus 4/3. So we have to remember when we're adding or subtracting fractions, the denominators have to be the same. All right, that's really important. If they're not the same, then we'll have to get them to be the same. But on this first one, they are the same, so we just have to remember the rule. When the denominators are the same, all we have to do is carry the denominator across. So we just rewrite the denominator, and then we can add or subtract the numerators. So 2 plus 4, we can add those together, that's 6. So now that we've turned it from two fractions to one fraction, we can try to simplify now. So 6/3, we can simplify that, and that simplifies down to 2. All right. Now on the second one, B, 3/5 plus 2/3, these are not the same. So we have to remember, well, how do we add fractions when the denominators are different? Well, we have to get them to be the same. So we have to find the smallest number that 5 and 3 will go into, right? And so you can kind of think of, well, what are the multiples of 5? All right, so 5, 10, 15, 20, 25. All right, and you can list them out, and then you can find the multiples of 3. So that's 3, 6, 9, 12, 15, 18, and so on. And so as soon as you find the first one that they have in common, the smallest one, that's the lowest common multiple, or the lowest common denominator. So in this case, it's going to be 15. All right, and so we're going to rewrite two fractions with a denominator of 15. Now all you have to do is figure out, well, what do you have to multiply this first fraction by, that first denominator, so it becomes a 15? Right now it's a 5. Well, we have to multiply it by 3. So we're multiplying the top and bottom by the same thing. And so 3 times 3 on top gives us 9. So 9/15 is the same as 3/5. All right, and then 2/3, okay, we have to ask ourselves, well, what do we have to multiply 3 by to make it a 15? Well, we're going to multiply by 5. So we're going to multiply the top and the bottom by 5. Right, and then 2/5, or 2 times 5 gives us 10, and 3 times 5 is 15, and 10/15 is the same as 2/3. Right, so now that we have the denominators the same, we can carry those across, just like the other one, and then add the numerators. So that's 19. And then again, we want to try to simplify if we can, but this doesn't simplify. All right, so we're going to first look at expressions, rational expressions, where the denominators are the same. All right, so again, we have to review our excluded values, how we did that. So remember the denominators that have variables, we set those equal to 0 and solve. All right, so on this first one, we have an x minus 2 in the denominator. If we set that equal to 0 and solve it, we're going to get 2. And then the other one, x minus 2, it's the same one, so we get the same excluded value. All right, so now the denominators are the same. We're going to carry that denominator across. Now, the numerators, we want to add the numerators together. Well, you can only add numerators if the terms are the same, right? So you can only add like terms. So x squared, there's no other x squares in there, so we're just going to carry that across. And then plus x, there's no other x's, and there's no other constant terms to combine. So we've turned two fractions into one single fraction. So once we get it into one fraction, we want to simplify it. Well, from the last lesson, we saw how do we simplify a rational expression. Well, we try to factor it and try to cancel things out. All right, so we can factor the trinomial on top. Okay, the denominator is just going to stay x minus 2. I'm going to put parentheses around it just because I like parentheses, so it contains it like a binomial. All right, so factoring this trinomial, we need two numbers that multiply to -12, but add to 1. And so that's going to be 4 and -3. All right, so use your x if you need to, so you can see it. It's x plus 4, x minus 3. And now we want to see, do we have any like binomials on top and bottom? We don't. So this doesn't cancel. Nothing cancels out, so it's simplified all the way. So that's how we're going to write our answer. All right, that's it. All right, number 2. Let's see, our excluded values. So we said our denominator is equal to 0. So we can set 5y equal to 0 and solve it. We divide by 5. And so we're going to get 0 for an excluded value. Now with subtraction of rationals, just like we did with polynomials, we never want to work with subtraction. We want to change it to addition. And we're going to distribute that negative to the top. So everything on top will change signs. Okay, you're just distributing the negative 1. All right, so you always have an addition problem. All right, so our denominators are the same, so we'll carry those across again, just like we did before. We'll combine like terms in the numerator. 3x squared plus negative 8x squared. We can combine those because they both have x squares, so that's negative 5x squared. And then plus 10, there's no other constant term, so I'm just going to carry that 10 down or across. All right, so I've turned two fractions that I'm adding into one single fraction. So this is where we try to factor, all right? And so on top, there's a GCF I can pull out. I can pull out a 5, or I could pull out a negative 5. It doesn't matter. Okay, so I'll just pull out the negative 5. All right, so I've divide by negative 5. Okay, so that's factoring the negative 5 out. And now the negative 5 in front, that's a monomial term. And then in the denominator, 5y, that's a monomial term also. So I can simplify. All right, so I can divide by 5. So they cancel out, just become 1. All right, so that's about it. So I have negative x squared minus 10 over y. Now, if you didn't factor the negative out with the negative 5 at the beginning, and you just pulled out a positive 5, then on the inside of the parentheses, it would be negative x squared plus 10. That's what would be left over. So either answer is fine. All right, number 3. All right, our excluded value looks like it's going to be positive 4. Again, we have a subtraction sign, so we don't ever want to work with subtraction. So we're going to change it to addition and distribute the negative. All right, so both signs change their opposites. So it's a negative 2x plus negative 8 on top now. All right, so we'll carry that denominator across because they're the same. We'll combine like terms in the numerator. Let's see, so we have an x squared, we have a minus 2x and a minus 8. All right, so we have a trinomial on top. Again, we've got to try to factor that. If it factors, then we factor it. If it doesn't factor, then it doesn't factor. Okay, not everything in the world factors, but you do have to try it. So you use your x so you can see it. So you're looking for two numbers that multiply to negative 8, but add to negative 2. So you should see it's minus 4 and plus 2. Right, so that's factored. Now we can see, well, we have an x minus 4 binomial on top and bottom, so we can cancel them out because they're exactly the same. And that looks like our final answer, x plus 2. I'll just keep it with the parentheses. All right, number 4, excluded values, set 2x plus 2 equal to 0 and solve it. All right, so you're going to have to subtract the 2 over and then divide by 2. It's going to be negative 1. All right, and then our denominators are the same again, so carry that across. So when we combine like terms, 4x squared plus 6x squared, those are like terms, so that's 10x squared. All right, so we've turned it from two fractions into one fraction. Now we want to try to factor. Well, the denominator, this time the denominator factors instead of the numerator. So we can pull a GCF out. I can pull a 2 out. So just cross that out. I'm left with x plus 1 when I pull the 2 out. All right, so now I have a 2 on the outside, which is a monomial term. X plus 1 is a binomial term. On top, 10x squared, that's a monomial term. So I can simplify monomial terms together. They don't have to be the same, as long as they're monomial terms. So 2 and 10, I know I could divide by 2. So if I divide by 2, that 2 cancels out, becomes 1, and then the 10 turns to a 5. So it looks like what's left, I have 5x squared over, and then x plus 1. All right, so remember that x plus 1 is a binomial, and you can't cancel the x with the x squared, because the 5x squared on top is a monomial term. All right, lowest common denominators. All right, so I'm going to practice. So remember, the lowest common multiple, or lowest common denominator, is the smallest number or term that both terms have in common. So for example, if we look at 4 and 6, if we list out all the multiples of 4, that's 4, 8, 12, 16, 20, 24, 28, 32. All right, so you're just taking 4, starting with 4, multiplying it by 1, and that gives you 4. And then 4 times 2, 8, 4 times 3, 12, 4 times 4, 16, and so on. And then you can do the same thing with 6, the multiples of 6. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, and so on. And then as soon as we find the first number that they both have in common, that's our lowest common multiple. But with fractions, it's also called the lowest common denominator. All right, and so 24 would be the lowest one. All right, so let's look at some of these other ones with variables. So with variables, we're going to be looking at monomial terms and binomial terms. So with monomial terms, you're looking at the variables, and if they're exactly the same variable, like x's or both y's, then you're looking at the exponents. And so the exponent that's highest is the exponent that you have to take for the lowest common denominator. So on number 1, we have an x to the first and an x to the fourth. And so x to the fourth is bigger than x to the first, so you have to take the x to the fourth as the lowest common denominator, or lowest common multiple. Right? So x to the fourth would be our common denominator that we would change both of them to get them to be the same. All right, number 2, we have a 2 and a 5. So here we have coefficients that we have to look at first. 2 and 5. So the smallest number that 2 and 5 would both go into, or that they both have in common, would be 10. All right, so 10 is part of the lowest common denominator that we're going to use. So now we have the x to the third and x to the sixth. They are the same variable, x's. So again, we have to take the highest exponent. So x to the sixth is higher than x to the third. Right, so bring down the x to the sixth. So it's just like a multiplication, 10 times x to the sixth. So 10x to the sixth is the lowest common denominator between these two denominators. So you want to try to take these in pieces, and then you just multiply them together. All right, number 3, 8x and 10y, those are monomial terms. So we're going to look at the coefficients first, 8 and 10. So you got to find the smallest number that they both go into. So you list out all the multiples of 8 and then all the multiples of 10. And hopefully you see it's going to be 40. Okay, so 8 goes into 40 and 10 goes into 40. That's the smallest one they have in common. Now we look at the variables. So you have an x and then there's a y. Since they're different variables, they're not the same, you have to take both of them. So you need x and y. And so again, it's just a multiplication. So 40xy would be the lowest common denominator. So when you have variables that are different, you have to bring them both in to the denominator. If they're the same, you take the highest exponent. All right, so number 4, we have binomial terms this time. So when you have binomial terms, you have to look and see, are they the same binomial, exactly the same number, same sign, or is there anything that's different? So on number 4, we have an x plus 2 and an x plus 3. Those are different binomials. Okay, one's a plus 2 and the other one's a plus 3, so they're not the same. Since they're not the same, you have to take both of them. All right, so x plus 2 times x plus 3. That would be our lowest common denominator. You need both of them. It's like having x and y. They're different, so you multiply them together. X plus 2 and x plus 3 are different, so you multiply them together. We're not going to actually multiply this stuff out. We leave it factored, okay? But you're just showing that you're multiplying them together. All right, so let's go ahead and do some of these problems now. So again, when you're adding and subtracting with unlike denominators, you need to find that lowest common denominator. And you can also get those excluded values. It's good practice for later on. And then we're going to figure out what we have to multiply each fraction by to get that denominator to be the same. All right, so let's look at this example, 2/5 plus 7 over 2. Again, we did a problem already like this at the very beginning of the lesson. And so I'm going to show you a way that you can kind of maybe skip a step on adding and subtracting fractions with unlike denominators. So hopefully you see the smallest denominator that 5 and 2 would go into is 10. Right. So I'm going to show you the long way first, and then I'm going to show you how you can maybe cut one of the steps out. All right, so normally what we would do is write two fractions, our denominator's 10. Then we figure out what do we have to multiply the first denominator by. Okay, what do we have to multiply 5 by to make it a 10? Well, we have to multiply it by 2. So that becomes a 4. And then you have to look at the second fraction. What do you have to multiply the 2 by to make it a 10? Well, you got to multiply by 5. So we multiply the second fraction by 5. That's 35. All right, and then we would carry that denominator across, and then add 4 plus 35 and get 39. So 39 tenths. Right? So what I'm going to do now is kind of show you where you can kind of skip that middle step. Okay, we're going to do the exact same work, it's just a little bit less writing. That's all. All right, so again, figure out what your lowest common denominator is. So in this case, it's 10. Figure out what do you have to multiply the first fraction by. Again, it's going to be 2. So 2 over 2. We multiply, we get 4. We bring that addition sign down. It's always addition. And then what do you have to multiply the second fraction by? So it's going to be 5. That's 35. So you can see now we have one fraction. Now we just have to combine like terms on top. Oops, that's 35, not 39. So it's 39 tenths. So you get the same answer, it's just a little bit less writing. So, you know, it's up to you. We'll show you another shortcut on fractions that you can use. It doesn't work on every single fraction, but a lot of them it will, as long as the numbers are small. So let me show you real quick. Let's say I want to add 3 fourths plus, say, 7 sixths. Not too bad. So one thing that you can do is you multiply the bottoms together. It's 24. That's your denominator. It may not be the smallest one, but it is a denominator that can be used. You just have to simplify more later. Then you multiply diagonally this way, plus, and then diagonally this way. And then you just add the top together, 18 and 28. That's going to be 46. Okay, and then you go ahead and simplify. I could divide by 2, so it's 23 over 12. Right? So it's a multiplication on the bottom. So here, I'll show you how you can do that on this problem also. So if we multiply, that's 10. Multiply diagonally, that's 4. Plus, diagonally this way is 35. Then we get 39 tenths. Okay, same answer. All right, so let's go ahead and do number 1. So our lowest common denominator between x and 2, since they're different, one's a variable x, the other one's a number 2, you need both of them. So it's going to be 2 and x, and so we multiply those together. That's our denominator, 2x. So then you figure out what do you have to multiply x by to make it 2x. Well, we have to multiply it by 2. So it's going to be 10 plus. Then what do you have to multiply the second fraction by? So what do you have to multiply 2 by to make it 2x? Well, we have to multiply it by x. So it's going to be 3x. All right, so now we have one fraction. We want to try to add the numerators together. So we have 10 plus 3x. Those are unlike terms, so you can't combine them. Now we want to check to see, could we factor the top? Well, there's no GCF, and we can't factor, and we can't cancel anything because that's a binomial on top. Okay, again, don't try to cancel the x's out, or the 2 and the 10. That 10 plus 3x is a binomial, so you can't cancel anything out. So that's going to be it. Right, so that's going to be our final answer, 10 plus 3x all over 2x. I'll keep that in parentheses. Our excluded value, again, comes from our denominator from the original problem, and since we have a variable x, if you set that equal to 0 and solve it, you're going to get 0 for the excluded value. All right, number 2, x minus 3 and x plus 2, those are different terms, and so different binomials, so you need both of them in your LCD. So I'm going to show that I'm just multiplying them together. I'm not going to actually multiply them. All right, so then you have to look at your first fraction, ask yourself, what do you multiply the first fraction by to get that denominator? What is x minus 3 denominator missing that the LCD already has? So hopefully you see it's missing x plus 2. So that's what we're going to multiply this by, x plus 2. All right, so you have to remember when we're multiplying, that means we're distributing. So 1 times x plus 2 just becomes x plus 2. Plus. Then you have to ask yourself, well, what's that second fraction missing? So what do you have to multiply x plus 2 by to make it x minus 3x plus 2? Well, it's missing an x minus 3, so that's what we have to multiply it by, x minus 3. So keep it in parentheses because you've got to distribute the 4 in. It's really important, so that becomes 4x minus 12. All right, so now I'm going to rewrite this denominator. Okay, x minus 3x plus 2 on the bottom. I'm going to combine my terms, so I have an x and a 4x. I can add those. That's 5x. And then I have a 2 and a negative 12. That's negative 10. All right. Now I want to check to see, well, maybe I can get something to cancel. I have to factor everything. So make sure everything's factored. So 5x minus 10, there's a GCF there I can pull out. They both have 5 in common. So I'm going to factor the 5 out. Okay, so if I factor 5 out, I'm left with x minus 2. Now I have an x minus 2 on top, but it's an x plus 2 on the bottom. Those are not the same, so you can't cancel them out. All right, so that's going to be my final answer. Nothing's going to cancel out, so I have 5 x minus 2 over x minus 3, x plus 2. My excluded value, again, comes from the original problem, from the denominators. So x minus 3, if I set that equal to 0, I'm going to get 3. And x plus 2 in the denominator, if I set that equal to 0, I'm going to get negative 2. All right, last one. So I have an x minus 2 binomial and then a 4. That's a monomial term. Since they're different, okay, a binomial and a monomial are never going to be the same. You need both of them in your LCD, so you just multiply them together. So 4 times x minus 2. Again, we're not going to distribute that in. We're just going to leave it to show that we're multiplying them. All right, so then figure out what are you missing, or what do you have to multiply the first fraction by to get that LCD. So it has the x minus 2 already. It's missing a 4. So I'm going to multiply top and bottom by 4. So 4 times 1 is 4 plus. And then you ask yourself, what's that second fraction missing? Well, it already has the 4, but it's missing the x minus 2. All right, so 1 times x minus 2 is x minus 2. I'm going to combine like terms. So 4 minus 2, that's going to be 2. So x plus 2 over 4 times x minus 2. All right, and I want to see, can I cancel anything? Nothing factors. It's already factored all the way. X plus 2 binomial. I'm going to put it in parentheses so you can see it. It's different than x minus 2 binomial, so I can't cancel anything out. So that's going to be the final answer. Okay, x plus 2 over 4 times x minus 2. My excluded value, again, is going to come from the original problem. I have an x minus 2 in the denominator, so if I set that equal to 0 and solve it, I'm going to get 2. The 4 I ignore because there's no variable with it. All right, so that's the basics of adding and subtracting fractions with unlike denominators.